All right, welcome. Let's take a look at the sapply function, which is the next function in our family of apply functions. And the sapply function works very, very similar to lapply, which works very similar to apply, and that's why they form a family. But the sapply function is going to try and coerce the results into a vector or a matrix or an array. So with lapply, the results are going to be displayed in a list always, and we know what's going to come out. With sapply, it's going to take those results and it's going to use the simplify to array function, which is a function that takes data in any structure, in any form, and tries to take that data and arrange it into some sort of array that our thinks makes sense. So it might arrange it into a one-dimensional array like a vector or a matrix or a three-dimensional array or even higher dimensional. So the sapply function takes the same inputs as the lapply function. We input a one-dimensional data structure that is a list or a vector. We indicate a function that we want to apply. We indicate possibly some additional arguments that go into our function. And then we have some additional arguments with sapply. One of them is a simplify argument. The default of sapply is to set simplify equals true, and that means it's going to try and take the results and coerce them and put them into an array of some sort. If we set this argument simplify to false, then the output is going to be a list, and we actually are doing the same exact thing that lapply does. So there's really no reason to set simplify equal to false in sapply. You can just go ahead and use the lapply function if you want the results to be in a list. And then there's also a use name argument, which is a logical value indicating whether or not name should be associated with results if we happen to have named the elements in our list as opposed to just use the default numbering for elements in our list. Okay, so one distinction here that's really important to note is that with lapply, we know the results are going to be stored in a list. With sapply, there's a little bit of uncertainty with how the data is going to be returned. R is going to try and coerce it into an array that makes sense, but that might not be what we intended. So we'll take a look at some examples to illustrate these points. So if I want to take our sample list, and this was from a code cell that we created earlier, a simple list, excuse me. So I'll run this simple list just so we can see what the data is that we're working with. So this was a list that had two elements. Each element was a vector of 10 integers. So if I say sapply simple list mean, it's going to apply the mean function to each element in the list. But the difference between sapply and lapply, when we did lapply, just to compare, we got the same values, but the results were stored in a list. With sapply, it said there were two values. You probably want this stored in a one-dimensional array, so it stored these values in a vector. Whereas lapply stored them in a list. And if for some reason I wanted them to be a list and I was using sapply, I could override that default and set the simplify argument to false. And now I get the same output as lapply. So these two commands do the same exact thing, just using lapply is more concise. So the sapply function seems more convenient because you can imagine what you might want to do is take one of these commands, run it, and then maybe do something with the output, and this is numeric output, so maybe it probably makes sense for this to be stored in a vector that we could use vectorized functions to work with. So that's what's nice about these apply functions, is that they work really nice with vectorization. But again, the sapply function, there's a little bit of uncertainty with how the results are going to be stored. And this could set a trap for us, and we don't want to spring that trap. So let's see what we're talking about with an example. So I'm going to create a very basic function called add2 that takes a vector as an input, a numeric vector, and going to return to, it's going to add 2 to every element of that vector. So I'm going to run this code cell that just created this function add2, and just to see what's going on, if I apply add2 to the vector that contains the numbers 2 and 3, it adds 2 to the first number to give me 4. It adds 2 to the second number to give me 5. Okay, so let's take a look at our simple list. We're going to apply the add2 function to each element of our list using sapply. So with sapply, it's going to try and guess what the output should be. So just keep in mind, what's going to happen is it's going to go into element 1 and it's going to add 2 to each of these elements. So we're going to get a vector of integers from 3 to 12. Then it's going to add 2 to everything in the second element. So we're going to get a vector of 13 to 22. And if I ran lapply, it's going to store the results in a list. If I run sapply, let's see what we get. We get a matrix. And so it chose to take this first element in the list, it added 2 to it, and then it stored it as a column in a matrix. And then it took this second element in our list, which was another vector, added 2 to it, and stored that as the second column in this matrix. So it stored it as a 10 by 2 matrix. It makes sense maybe that you got a two-dimensional matrix back. Why was it 10 by 2 instead of 2 by 10? I don't know, right? That's just what our guessed as far as how we wanted the results stored. And so we didn't know what to expect, and we could take this output and convert it to a 2 by 10 matrix by taking the transpose if we wanted to, but that required us to know what to expect out of this function. We know what to expect out of lapply. We know we're going to get a list. So this is what we would get out of lapply, or if we set simplify equals false. So that's the difference there, matrix versus a list of vectors. Let me create a different list called simple list 2. And here we're going to have the first entry is a vector that has length 3. So we have the integers 1, 2, 3. And in the second entry, we have a vector with 4 elements, 4, 5, 6, and 7. So now our elements in our list are numeric vectors, but they don't have the same length. And so if I try and apply the add2 function to each element of our list, it does that correctly, and it stores it as a list of 2 vectors, as opposed to the matrix that we got over here when we applied the same function to a different list. So when the list consisted of vectors that had the same length, it was able to set up a matrix of those values. In this case, our list had vectors of different length, so it was not able to create a matrix from those values because they had a different number of values in each of these entries. So it just kept it as a list. Okay, we'll take a look at vapply in the next video.